Dear students, on the last one we finished mixture of gases. Now we come to next part of unit 1, that is steam boilers. We begin with introduction of steam boilers under part 1. A boiler or steam generator is usually a closed vessel made of steel. Its function is to transfer the heat produced by the combustion of fuel, which may be solid, liquid, or gas, to water and ultimately to generate steam. What does it mean? It means solid fuel in the solid form, liquid form, or gaseous form is heated to produce gases. Those gases transfer their heat to the water filled inside the boiler and thereby convert it into steam or generate steam. Now, where this steam will be used? It may be supplied to an external combustion engine, EC engine, which are generally steam engines and steam turbines. These are prime movers which generate power. To generate power, they require fuel, and here the fuel is steam. So steam is passed into the steam engine to generate power or passed over the turbine blades to generate power. These are very common applications of steam. Now, at low pressures for industrial process work in cotton mills, sugar factories, breweries, etc., also steam is used. For producing hot water, which can be used for heating installations at much lower pressures, steam is generally required. Now, let us discuss some important terms related to steam boilers. Number 1, boiler shell. It is made up of steel plates bent into cylindrical form and riveted or welded together. The ends of the shell are closed by means of end plates. So this forms a boiler shell. A boiler shell should have sufficient capacity to contain water and steam, because water will be filled in it, and when this water is heated by some means, that will get converted to steam. So steam will be filled in the upper portion of the boiler shell, and in the lower portion there will be water. Another part is combustion chamber. It is the space generally below the boiler shell meant for burning fuel in order to produce steam from the water contained in the shell. So that fuel, which will be in solid, liquid, or gaseous form, will be put at the bottom of the chamber and burnt. So that burning place is called combustion chamber. Now, another important term is grate. What is grate? It's a platform in the combustion chamber upon which fuel, it may be coal or wood, that is burnt, right? So on that platform, you keep the fuel and ignite it so as to perform combustion process. So grate hota kya hai? Generally, it consists of cast iron bars which are spaced apart so that air, which is essential for combustion process, can pass through these bars. आपने पुराने जमाने में अंगीठी, अगर पुराने जमाने की अंगीठी देखी हो तो आपको थोड़ा आइडिया हो सकता है कि उसके अंदर जैसे आयरन रॉड्स होती थी, उसके ऊपर कोयला या लकड़ी रख देते थे और उसको बंद करके नीचे से हवा देते थे तो आग पैदा होती थी और उससे बर्तन में पानी भी गर्म करते थे, खाना भी बनाते थे. तो उसी का जो बड़ा फॉर्म है वो ग्रेट है. इसमें कास्ट आयरन बार्स हैं which are spaced apart and air can pass through them. The surface area of the grate over which fire takes place is called grate surface. Then what is furnace? It is the space above the grate and below the boiler shell in which the fuel is actually burned. Grate के ऊपर आप रख देते हैं fuel. So fuel is kept above the grate or over the grate and it is burned. So that upper part is called furnace, where fuel is actually burned and that produces gases. Those gases will pass upwards, thereby to heat up the water. So the furnace is also called firebox. Now heating surface. It is the part of the boiler surface which is exposed to fire. When fire is produced by burning the fuel inside the combustion chamber above the grate, it is some of the boiler surface is exposed to fire or hot gases which are produced out of that fire, right? That surface is called heating surface. Now, more important term is mountings and accessories. What are mountings? These are fittings which are mounted on the boiler for its proper functioning. Means if boiler has to function properly, these are the essential parts which are mounted on the boiler, right? So they include, examples are water level indicator, because water level is very important. When water level goes down, it has to be topped up. If water level is reached its maximum, the water entry has to be stopped. So there has to be water level indicator. Pressure gauge. Pressure gauge indicates the pressure inside the boiler shell. If it exceeds the limiting value, boiler may get burst, right? If sufficient pressure is not there inside the boiler, steam may not go to the required place properly, right? So a proper pressure has to be maintained inside the boiler while heating water. For that purpose, pressure gauge is there, safety valves are there, so that when pressure goes beyond the limiting value, these safety valves will open and release some of the steam so as to reduce pressure inside, so that boiler shell may not get burst and any damage may not happen, right? So these are essential things. A boiler cannot function safely without these mountings. So mountings are essential for any boiler. And what are accessories? These are the devices which form an integral part of a boiler but are not mounted on it. Accessories boiler के साथ लगती हैं, वो उसका पार्ट बनती हैं, लेकिन बॉयलर में नहीं लगाई जाती. For example, superheater. Superheater is to heat the air which is passed for combustion process through the combustion chamber. उसमें गर्म करने के लिए एक अलग से डिवाइस लगाई जाती है सुपर हीटर के लिए. इकोनोमाइजर इज अनदर डिवाइस which is used for heating the input water, जो उसके अंदर इनलेट हो रहा है वाटर का, उस पानी को पहले से थोड़ा सा इकोनोमाइजर में गर्म कर देंगे बिना किसी खर्चे के, वो थोड़ा गर्म होके आएगा, it will consume less fuel, right? I'll explain these things in detail later on, but these are the things which increase the efficiency of the boiler, right? They are not essential, because if these are not there, boiler will function perfectly. But if these are provided, boiler will function more efficiently, right? That is the basic difference in accessory and mounting. Now, what are essentials of a good steam boiler? These are general things which are self-explanatory. It should produce maximum quantity of steam with the minimum fuel consumption. Minimum is the fuel consumption, maximum will be the efficiency, right? If it produces maximum quantity of steam. Similarly, it should be economical to install. It should require little attention during operation. Means if during operation it requires continuous attention, then some manpower has to be deputed for that, which will be costlier. So system should be such that it should not require any attention and automatically it should function. Similarly, it should rapidly meet the fluctuation of load. If there are fluctuations of load, that fluctuation has to be met by the boiler so as to ensure proper functioning of boiler. It should be capable of quick starting. Sometimes boilers take too much of time. So if in power plants, etc., boiler starts in hours, then power production will be affected. Therefore, generally boilers are supposed to start quickly. It should be light in weight. In case of mobile boilers, particularly when you have to take it from one place to another place, it should be light in weight, and it should occupy small space, particularly in case of such boilers. The joints should be few and accessible for inspection. It is important. If there are more joints, there is more possibility of leakage of steam, right? And if steam leakage is there, for inspection, it should be accessible so that one can come to know from which point the steam is leaking, and that could be controlled, right? So joints should be as low as possible, and whatever joints are there should be accessible for inspection. Mud and other deposits should not collect on the heating plates. If on heating plates mud is deposited, there will be less heat transfer. So heat transfer is affected, means water will get less heat. If water gets less heat, its conversion from water to steam will be affected. So there should not be any deposits. Refractory material should be reduced to minimum, but it should be sufficient to secure easy ignition and smokeless combustion of the fuel on reduced loads. The tube should not accumulate soot or water deposits. जैसे अभी यहाँ बताया मैंने ऊपर हीटिंग सरफेस के केस में, ऐसे ही ट्यूब्स अगर सूट या वाटर डिपॉजिट्स को एक्यूमुलेट करेंगे, देन प्रॉपर फ्लो ऑफ वाटर और प्रॉपर फ्लो ऑफ गैसेस थ्रू द ट्यूब्स विल बी अफेक्टेड and should have reasonable margin of strength to allow for wear or corrosion. So these should not get corroded easily, otherwise the entire system will be affected. Water and flue gas circuits should be designed to allow a maximum fluid velocity without incurring heavy frictional losses. So there should not be any frictional loss again, so that fluid may pass through the tubes easily. It should comply with safety regulations as laid down in the Boilers Act. Boilers Act में जो भी safety regulations दिए गए हैं, उनका compliance fully होना चाहिए, जो भी boiler आप use करें उसमें. Now, how to select a boiler? Based on what we discussed prior to this, we can discuss some points or factors on which the boiler selection depends. Power required and the working pressure. कितनी पावर चाहिए, कितना वर्किंग प्रेशर चाहिए, उसके हिसाब से स्टीम बॉयलर हो सकता है कि आपको हाई प्रेशर बॉयलर रखना है कि लो प्रेशर बॉयलर रखना है, एट द रेट एट विच स्टीम इज टू बी जनरेटेड, इसके बेसिस पर आप डिसाइड कर सकते हैं वेदर टू गो फॉर फायर ट्यूब बॉयलर और वाटर ट्यूब बॉयलर. हालांकि ये क्लासिफिकेशन मैंने अभी बताया नहीं है, विल डिस्कस इट लेटर, राइट. जो जियोग्राफिकल पोजीशन ऑफ द पावर हाउस कितना दूर है, कहाँ है, उस पर भी डिपेंड करेगा कि किस तरह का बॉयलर आपको रखना है. Fuel and water availability, how much fuel is available there, how much water is available there, type of fuel to be used, किस टाइप का फ्यूल यूज करना है, इन सब पे डिपेंड करेगा कि हम कौन सा बॉयलर लें. and when you will see the classification of boiler, then you will be able to correlate these points with that. The probable permanency of the station and then probable load factor कितना होगा, इन सब पे डिपेंड करेगा कि हम कौन सा स्टीम बॉयलर लें. Now we come to the main part, that is classification of steam boilers. So there are many classifications of steam boilers. Some are important from the subject point of view. Number one, according to the contents in the tube. Tube में क्या contents हैं? The steam boiler, according to the contents in the tube, may be classified as fire tube और smoke tube boilers and water tube boilers. या तो fire tube boilers होंगे या water tube boilers होंगे. Fire tube boilers क्या हैं? जैसा as the name indicates, the flames and hot gases produced by the combustion of fuel pass through the tubes which are surrounded by water. Boiler shell में पानी भरा होगा, उसके अंदर से मान लो ट्यूब्स जा रही हैं, उन ट्यूब्स में से हम ये गैसेस पास करेंगे which have been produced by burning the fuel. Fuel बर्न किया, गैसेस आई, उन गैसेस को ट्यूब्स में से पास किया. Those tubes are passing through the boiler shell in which water is filled. Then those gases will transfer their energy, their heat to water, thereby converting it into steam, right? Heat is conducted through the walls of the tubes from the hot gases to the surrounding water, and water is converted to steam. Such a system is called fire tube boiler. Examples are simple vertical boiler, Cochrane boiler. Cochrane boiler तो इस समय टेक्निकल कॉलेज में लगा हुआ है, इंजीनियरिंग फैकल्टी में पहले था, अब नहीं है इस समय वर्किंग कंडीशन में. If anybody wants to see, one can go to the heat engineers lab of technical college and see the Cochrane boiler there, which used to work once upon a time. Then Lancashire boiler, Cornish boiler, Squash marine boiler, locomotive boiler, and many other boilers are there which are fire tube boilers, but these are very common, some of which you are going to study in the later part of this unit, right? In water tube boilers, water is contained inside the tubes called water tubes, which are surrounded by flames and hot gases from outside. क्या डिफरेंस हुआ इसमें? पानी ट्यूब्स में से पास होगा और जो गैसेस आ रही हैं वो गैसेस, those gases will surround the tubes and thereby transfer their energy to water. जो पानी बह रहा है ट्यूब के अंदर से उसको एनर्जी देंगी, and that water will be connected after receiving heat energy from few gases. That water will get converted to steam. Such a system is called water tube boiler. Examples of water tube boilers are Babcock-Wilcox boiler, Stirling boiler, Lamont boiler, Benson boiler, Yarrow boiler, Loeffler boiler, and many other boilers are there. Some of these boilers you will be studying in the later part of the unit, right? ये पहला classification है. Second classification, according to the position of the furnace. In the steam boilers, according to the position of furnace, can be classified as internally fired boilers or externally fired boilers. As the name indicates, if firing takes place, combustion takes place inside the boiler, then that will be internally fired boiler. In internally fired steam boilers, furnace is located inside the boiler shell. Most of the fire tube steam boilers are internally fired, right? But there are some externally fired boilers also, in which furnace is arranged underneath in a brickwork setting. इसमें क्या होता है? बाहर फायर किया, gases निकली, those gases are passed into the boiler shell through tubes, right? So water tube boilers are, इसमें always लिखा है, but generally externally fired. But there may be water tube boilers which are internally fired also, but rare cases are there. Number 3, according to the axis of the shell. If steam boiler shell is vertical, then it will be called vertical boiler. If boiler shell is kept horizontal, it will be horizontal boiler, right? अब एग्जांपल्स भी आप देख सकते हैं. वर्टिकल बॉयलर्स में तो एक सिंपल वर्टिकल बॉयलर नाम से ही पता चल रहा है, कॉकरन बॉयलर, these are vertical boilers. And horizontal steam boilers, Lancashire boilers, locomotive boiler, Babcock-Wilcox boiler, these are horizontal boilers. Now, according to number of tubes through which water may pass or gases may pass, फायर ट्यूब के बॉयलर है तो गैसेस पास होंगी, वाटर ट्यूब बॉयलर है तो वाटर पास होगा. बट इन बोथ केसेस इफ इट इज अ सिंगल ट्यूब, these are called single tube boilers. If it has multi tubes, it will be called multi tube boiler. In single tube boilers, there is only one fire tube or water tube. Simple vertical boiler or Cornish boiler are the examples of single tube boilers. In multi-tube steam boilers, mostly we have multi-tube steam boilers. There are 2 or more fire tubes or water tubes. Lancashire boiler, Cochrane boiler, Babcock-Wilcox boiler are multi-tube boilers. Now, according to the circulation of water and steam, अगर natural circulation है या forced circulation है. Generally, water circulation is natural in most of the boilers, and the flow is by natural convection currents, which are set up during the heating of water, right? And in forced circulation steam boilers, there is a forced circulation of water by a centrifugal pump driven by some external power. Some power has to be given. That will be the expense of additional energy. And use of forced circulation is made in high pressure boilers generally. जिसमें हमें high pressure generate करना है, उसमें हमें circulation centrifugal pump से water को forced circulation देना होता है. Such as Lamont boiler, Benson boiler, Loeffler boiler, Welcon boiler. These are examples of high pressure boilers which use forced circulation, right? ये boilers जब आपको explain करेंगे तो थोड़ा और समझ में आ जाएगी ये बात. Now, according to the use, steam boilers may be classified as stationary or mobile boilers. Now, stationary boilers are used in power plants or industrial process work. बड़े बड़े पावर प्लांट्स हैं, वहां पे तो बॉयलर एक जगह रहेगा और for years together it will generate steam and send to the big turbine plants, right? So these are called stationary boilers because they do not move from one place to another. Mobile steam boilers are those which move from one place to another. These boilers are locomotive boilers. Locomotive boiler आपने देखा होगा, लोकोमोटिव इंजन्स देखे होंगे आपने, पुराने पिक्चरों में देखे होंगे, पता नहीं लाइव देखा है कि नहीं कभी, जिसमें स्टीम निकलती है, उसके अंदर आगे के पार्ट में स्टीम इंजन होता है, पिछले पार्ट में बॉयलर होता है, उस बॉयलर में स्टीम जनरेट की जाती है, वो स्टीम इंजन में भेजी जाती है, स्टीम इंजन में पिस्टन वर्क करता है, पिस्टन ट्रांसफर एनर्जी टू कनेक्टिंग रॉड एंड देयर बाय टू क्रैंक शाफ्ट रोटेट करता है, पावर मिलती है, दैट पावर ड्रैग्स द एंटायर सिस्टम, राइट? So these are examples of mobile steam boilers. Marine boiler है, वो भी साथ साथ चलता रहता है उसके बॉयलर, तो मोबाइल हो गया. Now according to source of heat, they can be classified according to the source of heat. These may be combustion of solid, liquid or gaseous fuels, hot waste gases or byproducts of some chemical processes, electrical energy, nuclear energy. जो फ्यूल हमने लिया उसके बेसिस पे हम कहेंगे सोर्स ऑफ हीट इसका ये है. अगर हम हॉट वेस्ट गैसेस से उसको रन कर रहे हैं तो ये सोर्स ऑफ हीट ये हो गया. बेसिकली वी हैव टू गिव हीट टू वाटर, विच एवर सोर्स वी यूज, वी हैव टू प्रोवाइड हीट टू वाटर टू कन्वर्ट इट इनटू स्टीम. ठीक है ना? न्यूक्लियर एनर्जी लेंगे अगर तो उसके हिसाब से न्यूक्लियर बॉयलर कहलाएगा, एंड सो ऑन. Now finally we come to comparison between water tube and fire tube boilers. In one column we have written details of water tube boilers and corresponding details of fire tube boilers are in this column. The one by one we can go through quickly. Water circulates inside the tubes which are surrounded by hot gases. This I have already explained to you. I hope you have understood. Whereas in case of fire tube boilers, hot gases from furnace pass through the tubes which are surrounded by water. Right? Now, basic difference is here. The water tube boiler generates steam pressure up to 250 bars, whereas fire tube boiler generates steam pressure up to 25 bars. See the difference. 10 times more pressure is generated in case of water tube boiler. So, whenever there is a less requirement of steam pressure, one can go for fire tube boiler. Rate of generation of steam is 450 tons per hour in case of water tube boiler, whereas here it is up to 9 tons per hour. Do you see the difference? So whenever there is less requirement of steam generation, less requirement of pressure, that means in small systems one can go for fire tube boilers. Floor area required is less, here it is required, here floor area required is more. Overall efficiency with economizer is up to 90%. Means if you are using economizer to heat up the inlet water and increasing its efficiency, it can go up to 90%, whereas here it can go up to 75% only. Because transfer of heat energy in case of water tube boiler is more effective than fire tube boiler. Right? Now, another point, can be transported and erected easily as its parts can be separated, whereas transportation and erection are difficult. Actually difficult दोनों ही होते हैं, but here we are talking of relative. It's a relative comparison. So relatively it is easier in case of water tube boiler. Preferred for widely fluctuated load. Fluctuating loads को cater कर सकता है water tube boiler as compared to the fire tube boiler because it can cater for a shorter period only. This sudden increase in load, right? Direction of water circulation is well defined in case of water tube boiler. From which direction to which direction water will flow. Whereas in case of fire tube boiler, water does not circulate. It is filled in the boiler shell and gases are circulated through the tubes, right? So that is the difference. Operating cost is high in case of water tube boiler as compared to fire tube boiler. bursting does not cause any destruction to the whole boiler. It's again very important. Whereas here bursting causes greater risk and damage to the property. Although all precautions and care is taken to ensure that bursting does not take place, but if at all take place due to some problem, it is more dangerous in case of fire tube boiler. And since its steam generation capacity is more, steam pressure generated is more, it is used in large power plants, whereas fire tube boilers are generally used in process industry, right? So with this, we come to the end of first part. I hope you have understood all this. In the next part, we can discuss economizer, the boiler mountings and accessories separately, right? So till then, goodbye. We'll meet in the next lecture.